Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the next problem that I am going to take today. It's a question based on the topic of three-dimensional geometry. It says a straight line drawn from the point P 1, 3, 2 parallel to the line x minus 2 divided upon 1 equal to y minus 4 divided upon 2 equal to z minus 6 divided upon 1 intersects the plane L1 x minus y plus 3z equal to 6 at the point Q. Another straight line which passes through Q and is perpendicular to the plane L1 intersects the plane L2 2x minus y plus z equal to minus 4 at the point R. Then which of the following statements are true? Now students, if you are thorough with the basic concepts of three-dimensional geometry, then it is a simple problem to solve. First of all, we will be writing the equation of the straight line passing through the point P and parallel to this given line. Now we know that whenever two lines are parallel to each other, then their direction ratios are same. So that means the equation of this particular line passing through the point P will have the direction ratios 1 to 1. Fine. So that means the equation of the line passing through the point P can be written as x minus 1 divided upon 1 equal to y minus 3 divided upon 2 equal to z minus 2 divided upon 1. Now students, I will be writing the general coordinates of any point lying on this line. And it becomes lambda plus 1, 2 lambda plus 3, lambda plus 2. Now to find the coordinates of the point of intersection of this line with the plane L1, I will be substituting these general coordinates in the equation of the plane. So it becomes lambda plus 1 minus inside the bracket 2 lambda plus 3 times lambda plus 2 equal to 6. Now just simplify this equation. So what do you get? You will be getting 4 lambda minus 2 lambda, it is 2 lambda, 6 minus 3, which is 3, 3 plus 1, it is 4. And 2 lambda plus 4 becomes equal to 6. So that means 2 lambda is equal to 2 or lambda is equal to just 1. Now students, put the value of the lambda obtained in the general coordinates. So from here, you will be getting the coordinates of the point of intersection, which is Q. So the coordinates of Q become 2, 5, 3. Right? Now students, we move further. Now students, we have to find the equation of another straight line which is passing through the point Q and perpendicular to the plane L1. Now we know that if the equation of the plane is ax plus by plus cz plus d equal to 0, then a is to b is to c become the direction ratios of any line which is perpendicular to the given plane. Now since the equation of the plane L1 is x minus y plus 3z equal to 6, so that means the direction ratios of this required line are going to be 1 is to minus 1 is to 3. So that means the equation of this line can now be written as x minus 2 divided upon 1 equal to y minus 5 divided upon minus 1 equal to z minus 3 divided upon 3. Now students, I will again be writing the general coordinates for this line. So they become mu plus 2, minus mu plus 5, 3 mu plus 3. Now this particular line is intersecting with another plane L2, and the equation of L2 is given as 2x minus y plus z equal to minus 4. So what you have to do to find the coordinates of the point of intersection, that is R, you will be just substituting these general coordinates in the equation of the plane L2, right? So now just do the calculations. It becomes 2 times mu plus 2 minus inside the bracket we have minus mu plus 5 plus 3 mu plus 3 equal to minus 4. It becomes 2 mu plus 4 plus mu minus 5 plus 3 mu plus 3 equal to minus 4. Right? Now it becomes finally 6 mu, and this is going to be plus 2 equal to minus 4. So from here we get 6 mu equal to minus 6 and mu is just equal to minus 1. Now students, put the value of mu obtained in the general coordinates to get the coordinates for the point R. So the coordinates of R become 1, 6, 0. Right? Now clearly the option B is incorrect, because in the option B it is given the coordinates of the point R are 1, 6, 3. So that is incorrect. Now we check the first option, the length of the line segment PQ. Now the coordinates of P are given to us as 132 and Q we found as 253. So just apply the distance formula, you will be getting the length of PQ. It becomes square root of 1 square plus 2 square, which is 4, plus 1 square again. Now finally this is square root of 6. So that means option A is correct. Now students, we move further and check the other options. Now students, we check the option C. In order to check the option C, we need to find the coordinates of the centroid of the triangle PQR. Now we have the coordinates of P as 1, 3, 2. The coordinates of Q are 2, 5, 3, and the coordinates of R are 1, 6, 0. Right? Now just use the formula to find the coordinates of the centroid of the triangle. So the coordinates of the centroid of the triangle PQR become 1 plus 2 plus 1, which is 4 divided by 3. Then we have 3 plus 5 plus 6, which become 14 divided by 3. And lastly, we have 2 plus 3 plus 0, that is 5 divided by 3. So that means option C is correct. Now students, we check the last option D. And to check the option D, we need to find the perimeter of the triangle PQR. So that means we need to calculate the lengths of all the sides of this triangle. We have already found the value of PQ as root 6. Now we just need to calculate the remaining two lengths. And for this purpose, you can obviously use the distance formula to find the distance between 2 points. So QR becomes square root of 1 plus 1 plus 9, and RP becomes square root of 0 plus 9 plus 4. So finally it becomes square root 6 plus square root 11 plus square root of 13. Now in the option it is given root 2 plus root 6 plus root 11. So that means option D is incorrect. So that means only two options are correct, A and C. Now students, next problem I will be posting in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.